Yeah, hello, Mr. Marconi. Here is the circuit. I'm not sure if you can see everything. This is DTFF. FF it means flip-flop. On DT it means I forget something something flip-flop. Uh, and it's a NAND gate. This is a division 1 by 5 that I've already made those files. I saved them and I just copy it right now because if I have to make it again, this LED from here, it will switch on and off after each finished cycle. So if it will count to 5, it will bright this LED, and if it will count again to 5, it will get off the LED, and so on. And here are some little, these guys here are very interesting helpers to see exactly the bits that are on and off. Right now is not running anything, but it will run in a second. Here, this is a 7493 chip, like you specified. This is a memory chip. Unfortunately, I couldn't use your memory chip. Or this is the memory chip that is inside this program, Proteus database. So we will use this, and it's working right now. I had a big problem with it to actually make it work and not give me a ton of errors. The program itself, he's expecting some files to be loaded, some hex files, and I had to manually make one. Actually, I can show you here. And this is the termination of the file. This is the smallest hex file that I could make, that I learned to make it, and it contains absolutely nothing. It's empty, but it's a functional, an empty functional hex file that you must load it inside this. Come on, disappear. Inside this memory chip, and from here I'm not sure how I will be able to actually code. Probably I will have to write this manually. I have no fucking idea how to make it yet, but I will figure it out. And then load it here and then test it. And this is a 74138. I think you had one as well, like this. It's a decoder, if I remember right. Here, this is my doing here, because when I'm powering, this is keeping everything to high and only one to low. And I switch it. This is an inverter, and I switch it everything to low. And when this is low here on this pin, this is low, the output. Here it will be high, and it will actually power my NPN transistors. I think I get your point why you use PNP, because this is outputting a low 0 volts, and you had to to ground it. It's a bit more easier for you probably to use. Yeah, but it's an option. You can use it like this. And I managed to lit up only the columns, not the lines. So is cycling between the columns. You'll see in a second. So let's run. Let me find a good spot here to center this, because it's shitty one. It doesn't have scrolls. This is a big mistake of them. Those who made this program, they didn't include scrolls, and you cannot zoom because it's a special key for that. Is a shit. So now I play it. I put here a clock of 1 hertz. Let me show you actually. Come on. So frequency 1. It means 1 hertz. For this clock, I press cancel. I have a jumper here, and I can manually switch the clock with my mouse clicks. So now I'm running it. I can switch it. This is it. This is what it's doing, is cycling the columns, powering each parallel, like you see, each parallel transistor. I put, I didn't manage to figure out how to link the remaining 2 from the 7 transistor left. I guess I will have to also the other NOR gates, inverters, and it's doing the column switching right now, exactly as you said, actually. But as to be sincere, from this point, I have no fucking idea how to make it work. I mean, I'm not sure. I don't know. I will have to. This guy is having 7 or 8 outputs, probably from this memory somehow. I never worked so deep. For me, this is deep stuff, and yeah, I really don't know how to make it work. Yeah, it's progress. It's a progress right now. Also this motherfucker, it's not actually this component, this LED matrix component that I have here. It's from the database of this program Proteus, and it's actually more simpler here than in reality. It's not, as you can see, if you count here, it's having 5 lines, 5 pins, and here it's having 7 pins. But our LED matrix is having 7 and 7. So we have to. It's actually more simpler here, because this is column. It's designated the columns here on this 5. And these 7 are the lines. It's actually much more easier to drive this thing here in this simulator. We will do it like this for a while. And like I said to you, I have already, I think I made a purchase on AliExpress, and I buy this guy, 74138 decoder. And until 2 months from now, probably it will arrive 10 pieces. So not only one single one, but 10 of them, because I wish to buy 100 of them, but it's too much. It's expensive. It wasn't expensive at all, actually. I really like the price of it. It costs like $2, which is very good price. It's fine. It's good. But, they are summing up every kind of every type of chip that I'm buying. Each of them is $2, $3, $2, $5, and so on. And I'm kind of getting to a sum of money that is too much. I wished I had every type of chip of IC under $10, but everything. This is the dream. But yeah, I get it. In time, I will make a collection of everything. It's exactly what I was doing until now, and I'm still doing it. I'm collecting on the road, walking and stepping and collecting stuff. So this is the progress. Let me actually run it again and show you the stepping, manually stepping. Pay attention in this sector where when I'm pressing here is with my mouse, it's not working faster, but I can slow it and leave it there, manually. It's like touching two wires, This is manually stepping, which is very exceptionally good for debugging stuff. And yeah, and right now if I'm clicking the jumper, it will be automatic again. You see, it's doing its thing by itself. So yes, this is it. Thank you very much for watching. To show you this LED, what it's doing, if you didn't figure it out already. So when it's reaching this bit, and then the last one, now is on, and then is reaching this bit, 4, 5, now it's off. And this is all that is doing, that LED, because of that flip-flop. If that flip-flop wasn't there, it wasn't switching like that. So yes, this is it. Thank you very much, and see you later, I suppose. All right. Bye-bye, Mr. Marconi.